morning students. Today we are going to see molecular orbital energy level diagram for HF molecule. See, this HF molecule is formed. Here there is the combination of hydrogen plus fluorine and there is formation of HF molecule. When we see the electron configuration of hydrogen, it has the atomic number 1. Electron configuration is 1s1. And this fluorine having the atomic number 9, its electronic configuration is 1s2, 2s2, 2p5. This 2p5, that is 2px1, 2py2 and 2pz2. See, when we consider the electronic configuration, here the combination of 1s orbital, here combination of the 1s orbital of hydrogen with the 2px orbital of fluorine, with the 2px orbital of the fluorine. See, here according to the LCAO, the atomic orbital combination is possible when they have the same symmetry, same geometry and nearly the same energy. See here, 1s orbital having nearly the same energy in the 2px with the 2px orbital. Is it possible? Yes, it is possible. How? Because here hydrogen is highly electropositive. It has the lowest electronegativity, while fluorine is highly electronegative. Fluorine is highly electronegative, hydrogen is highly electropositive. There is large difference between the electronegativity, and that's why the orbitals of the fluorine have the lower energy. Orbitals of the fluorine have the lower energy, while this hydrogen 1s orbital have the higher energy. And so when we can consider the particularly energy axis, and on this energy axis, when we will be start here, it is the 1s orbital, where it is the 1s orbital of hydrogen atom. And when we can consider the 1s orbital of the fluorine, here it is the 1s orbital of the fluorine. See, then here it is the 2s orbital and here there is the 2p orbital. In this 2p there is the 2px orbital, and so that there is the combination of these. Energy difference between these is very less. So this combination is possible. Always we see that 1s will be combined with 1s, but here 1s having the very low energy, and this difference, when we can calculate this difference, this is very high difference. And so that here in terms of the energy, in terms of the symmetry, in terms of the geometry, there is the matching geometry symmetry is of the 1s orbital of the hydrogen and 2px orbitals of the fluorine is possible. Then remaining orbitals, see these remaining orbitals, they remains as non-bonding, they remains as non-bonding, they remains as a non-bonding orbitals. They are the non-bonding orbitals, and so that the non-bonding orbitals there is no need to show in our particular diagram. And when we are going to see the diagram of this particularly HF molecule, at one side there is the hydrogen, at another side there is the fluorine. See, when we consider here it is the 1s orbital, this 1s orbital is here, and when we can consider it is the only 2px orbital, only the 2px orbital. And when we consider the combination, see these are the atomic orbitals of hydrogen, it is the atomic orbital of fluorine, and when we consider their combination, see this combination will be particularly here. this combination particularly, there is the see 1s orbital, and here there is the sp combination. Here there is the sp combination. In this sp combination, it can use the sigma bond. It can use the sigma bond. So there are the orbitals. When this 1s orbital and 2px orbital, they will be combined. One orbital having the lower energy than the atomic orbitals, another having the higher energy than the atomic orbitals. The orbitals, due to the combination of this sp, it is called as the sigma sp. It is called as the sigma sp, and this is called as the sigma star sp. This star indicates that the higher energy. This star indicates that the higher energy. Thus, there is combination of the 1s orbital of the hydrogen and 2px orbital of the fluorine. Due to the combination of these two, we having the two orbitals, one BMO, which is called as the sigma sp, and another is called as the sigma star sp. See electron configuration. In 1s orbital of hydrogen, there is single electron. Then here in the electron configuration, 2px1. So for our convenience, we can take this single molecule. Single electron. Now these two electrons, they are enter into the molecular orbital, and now we are having this picture. See, then there is the bond order. Bond order is equal to 1/2 in bracket electrons in BMO minus electrons in ABMO. So 2 minus 0 is equal to 2 by 2 is equal to 1. Bond order is 1. Then the energy evolved. See, the energy is equal to electrons in BMO 2 into minus beta plus ABMO 0 into beta. So is equal to minus twice beta plus 0. That means minus twice beta amount of energy is released, and molecule will be get stabilized. Another thing, we know that there is large difference between the electronegativity. There is large difference between the electronegativity, and due to that, this HF molecule becomes the polar. It having the partial positive charge and partial negative charge. This polarity is explained. See, this sigma sp, that is the bonding molecular orbital, it is close to fluorine atom, and it is away from this 1s orbital of the hydrogen. That means there is away from this orbital, that is the antibonding molecular orbital, close to the 1s orbital and away from the 2px orbital of the fluorine. That means electron density will be pulled towards the fluorine, and as this electron density will be pulled towards here, it acquires this partial negative charge. It acquires this partial negative charge. It acquires this partial positive charge, and this molecule will become the polar one. So here HF molecule can be formed by the combination of hydrogen and fluorine. Here 1s orbital of the hydrogen combines with the 2px orbitals of the fluorine atom. This combination is possible, that will be seen on the energy axis. Due to the similar energy, this sp combination always gives the sigma bond. So there is the bond between the fluorine and hydrogen. It is the sigma bond. Once it will be established, this bond, the electron density will be pulled towards the fluorine, because fluorine have the more electronegative nature, and that's why this molecule will become the polar one. This molecule will become the polar one. Bond order is equal to 1. That means there is single bond between the hydrogen and fluorine. Energy evolved, it is minus twice beta. Molecule also get stabilized. Thus, HF molecule can be exist, it is formed, and it is polar molecule. Okay, thank you.